Hello, today in this video we will study energy stored in a charge capacitor. So first consider a capacitor of capacitance C. Suppose that the capacitor does not possess any charge initially. That means initially the charge on the capacitor is 0. Okay. On being connected to a battery, suppose that it charged to a potential V after some times. Okay, now see. Initially, uh, initially the capacitor has charge 0. After connecting to a battery of potential V, the capacitor charged to Q. Okay, the charge becomes Q. Okay, after some times, slowly it is charging, and after some times the capacitor charges to Q. Okay, now we know that uh, at at this point when the capacitor charged to Q, the capacitance is given by C equal to Q by V. Q by V. Okay, after some times when the capacitor has charge Q, at that time the capacitance is Q by V. Okay, see, initially the capacitor has charge 0. After connecting to battery of voltage V, the capacitor start to charge, and slowly the charge on the capacitor increases, and after some time, let's say T, the charge on the capacitor is Q. Okay, and at that time the capacitance is given by C equal to Q by V. This is the formula for capacitance. Okay, now from this formula we are getting this. Okay, so C into V equal to Q. So Q equal to CV, and then uh, in terms of V also you can find. Keep V in one side and take C in the other side, so the C will go in the downside. So make this equation 1. Now suppose that the battery supplies an infinitesimally small amount of charge dq, to the capacitor at constant potential V. Okay, here see the battery is supplying charge very small. Okay, small amount of charge dq. Okay, dq like that, and at time t all this charge dq, the total charge become q. Okay, now so according to the definition of potential, so potential difference. So what is the definition of potential difference? V equal to what? Work done, work down per unit charge, right? Q, W by Q. So this is the definition of potential difference, right? Okay, now here see our question is energy. So whenever they ask us to find energy, we have to find what? Work. So that means we need this work. Okay, work. So work equal to V into Q. VQ. So this is the formula for work. Okay, work. Now here, since um, charge is supplied in small quantity, dq. Okay, dq. So that means this work is also small work. Okay, so small work dw equal to v, charge is small charge dq. Okay, now from here, after this, see v value we already found. V value is q by c. Now put here. Okay, q by c. Now this is small work done. Small work. Okay, but we have to find the total work. Okay, the total work from when the charge is 0 to q. Okay, 2 to q. So what is the total work? So we have to integrate from 0 to q because initially the charge is 0 and at the final the charge is q so from 0 to q. Okay, q. So 0 to q. Now q by this, q by c, q by c, dq dq. Now here integration is with respect to dq that means q. This c is constant, so we can take outside so we can take c outside. So 1 by c integration 0 to q, q dq. Okay, now what is the integration of q dq? It is similar to like this x dx. Integration of x dx is what? X 1 plus 1 divided by 1 plus 1. So it is x squared by 2, right? So now in place of x we are given q so in just write q in place of x. So q squared by 2 is the integration. So this is q squared by 2 so the limit is from 0 to q. So 2 is constant, you can take outside, so it will become 1 by 2c. Now and inside only q square will be left now put the this final limit is q so in place of this q just put q, so it will be the same only q score minus next in place of q we have to put 0, so 0 score is 0 so we will get w equal to 1 by 2 q score, 1 by 2 c into q score. So this is the total work done. So now this total work done is stored as potential energy. Okay, electric potential energy inside the capacitor. So energy is denoted by U. Okay, potential energy so just replace W with U. Okay, so this is the potential energy. U equal to 1 by 2 C Q square. Now substituting Q equal to CV. So this value we are getting this by C equal to Q by V so Q equal to CV. Okay, Q equal to CV. So in place of Q just put CV. So this is Q, so CV means score is there so we have to score. So from here 1C and 1C will cancel, so we will get 1 by 2 CV score. Okay, now second step. Now we have replace C. Okay, see here um what are the quantities? We have Q and C first replace for Q. Okay, after that we have to replace for C also okay, Q1 is done. Now we have to replace for C. Okay, from the same formula this formula. Now Q by V equal to C, na? Yeah, if you take this V in the other side, then it will go downside, na? So C equal to Q by V. Now use from in this equation, put C value. Okay, so what is the equation? 1 by 2 C Q score. So Q 1 by 2 Q score. So C value is Q by V, na? So Q divided by V, so this V will come outside, na? Upside, na? So V. Okay, and 1Q and 1Q will cancel, so 1 by 2 QV. So this is the uh, energy. Okay, energy here we are getting three energy, na? With different term, so we can combine all together. Okay, so we will get 1 by 2 CQ score. So this is the first one, na? 1 by 2 CQ score, and the second one is 1 by 2 CV score. This is the second one, 1 by 2 CV score. Third one is 1 by 2 QV, na? 1 by 2 QV. So this is the third one. You take classwork. Question: A capacitor of capacitance 50 microfarad is charged to a potential of 1000 volt. Calculate the energy stored in the capacitor. Calculate the energy stored in the capacitor.